Today we're going to talk about Rose curves. So we have r equals a cosine n theta, or r equals a sine n theta for our general equation for a Rose curve. And we have already done some graphing discovery where we discovered when n is equal to an odd number, the number of petals is equal to n. When n is equal to an even number, the number of petals equals 2 times n. We also found the length of each petal is equal to the absolute value of a. We can find the spacing between each petal by taking 360 degrees divided by the number of petals if you're using degrees, or if you're using radians, you would do 2 pi over the number of petals. So for this, we have the petals starting in different places depending on if we're working with cosine or with sine. So the first graph we're going to look at is a cosine graph, and the first petal is going to occur at 0 degrees. Now, sine's first petal is slightly different, which we'll talk about where that occurs at. And if we have an a value that's negative, multiplying by -1 is going to reflect the rows over the axis. So let's go ahead and take a look at our first equation. So for our first equation here, we have r equals 8 times the cosine of 5 theta. So if we look at some of our information, our n value is equal to 5. Which means that we have 5 petals because n is odd. And then we know that the petal length is equal to the absolute value of 8, so 8. And because this is cosine, we start on the polar axis. At 0 degrees, since we're going to use degrees when we're graphing these because I found it's easier to use degrees. You can also use radians though. And for the distance apart, for the distance between, you have 360 degrees divided by the number of petals, which is 5. So that means 72 degrees between each of our petals that we have. So now for this, if we think about our graph for cosine, and we're going to do the r value analysis. So we have, this is r and this is theta. And again, r equals 8 cosine 5 theta. So if this is instead y equals equation, y equals 8 cosine 5 theta. We've talked about graphing these before. 8 is the amplitude, and 5 is our b value. So remember that b times the period, if you're using degrees, would be equal to 360 degrees. If you're using radians, b times the period equals 2 pi. So we can find the period by taking 360 degrees divided by b, or if you're using radians, the period is equal to 2 pi divided by b. And notice in this case, your b value is the n value, so that's going to give you the period. So the period for this graph is equal to 360 degrees divided by 5, which is 72 degrees. Then if we want to figure out the key points of our graph, remember we said the key points, you take the period and divide it into 4 equal parts. And so in this case, the period is 72 degrees, so your key points are going to be equal to 72 degrees divided by 4, and that is 18 degrees. So we would have 18 degrees. Then if we add another 18 degrees, we get 36 degrees. Another 18 would be 54 degrees, and another 18 is 72 degrees. And so because this is cosine, we know cosine starts up here, or because it's positive, at positive 8, then it goes to the midline, which is at 0, -8, back to the midline, and up. So we know that's our cosine graph. So because cosine is a positive a value here, that's why we're starting at 0. So cosine graphs will always start at, like we said, the polar axis 0 degrees, or if it's a negative in front, we would be starting at -8, you would start on the other side. So that's why our first petal that we have is going to be, at this case, at 0 degrees. And the petal length we already said was 8. So on my graph here, I'm going to go out a distance of 8 from the origin or the pole. So 1, 2, 3, 4, 5, 6, 7, 8 would be right here. So that's where we're starting. So we have petals at, the first one would be 0 degrees, and then we said the spacing between each petal is going to be 72 degrees because they're always equidistant apart. So the next petal is going to be at 72 degrees. So I'm just going to do that distance of 8 from the pole or the origin, and we're going to go to 72 degrees, which would be in between 70 and 80 degrees, so somewhere right there. Then if we add another 72 degrees to that, we get 144 degrees, which would be somewhere in here. Add another 72 degrees to that, and we get 216 degrees. For the next petal, so out a distance of 8 at 216 degrees. So it's always easier if you find the degrees first, and then do the distance from the pole. And then add another 72 to 216, and we get 288 degrees. Which would be somewhere in here. Now, there's a way to figure out how wide your petals are going to be based upon where your zeros are hitting at on your graph, but we're not going to worry about that for now. I'm just want you all to be able to, oops, I just moved that. I just want you all to be able to get those points and then graph them. And there is usually an order to which you're graphing them. So we know that the first one goes to from 18 degrees. If we go back up here, we know we have a petal at 18 degrees, and then notice that at 36 degrees, we're in the negative R value range. So remember, when you're in the negative R value range, you add 180 to that. So our graph just kind of curves around. So we know this is going to go into the pole, and we're going to be making these leaves that we have here. And again, I'm not concerned with the order, so if you just want to go ahead and draw the leaves, that's fine. So we're just going to draw them as best we can. So that would be my rose curve. Now, if instead we had a negative value in front, so I had R equals -8 cosine of 5 theta, then I would multiply by -1. So our graphs would just reflect on across the line theta equals 90 degrees, which would be your y-axis. So your graph would just be reflecting over this line. So instead of starting at 0 degrees, you would start at 180 degrees out a distance of 8 would be the difference. So I just wanted to point that out. So again, your starting point would start over here instead, and then your graph would just reflect. So looking at the next one, we have R equals 8 sine 5 theta. So the sine graphs are a little bit more tricky because we don't start on the polar axis, and sine graphs don't always start on the y-axis, which really isn't your y-axis. It's the line theta equals 90 degrees if you're using degrees, or theta equals pi/2 if you're using radians, which is what makes sine a little bit more difficult. So for this one, n is equal to 5, just like the last graph. So we know that we have 5 petals. And we know that the petal length is also 8. And for this one, we know the distance apart is the same. So it's still 360 degrees divided by the number of petals, which is 5. So it's still 72 degrees. But we have to figure out where our first petal is going to be. So the question is, how do we do that? So we're going to use our R-value analysis graph to kind of help us. So I'm going to go ahead and graph this. So R theta, and again, R equals 8 sine 5 theta. So we know for this one, we've just said in the last one that the period is equal to 360 degrees divided by 5. This is divided by your b value, which gives us 72 degrees. And then we said the key points are equal to the period divided into 4 equal parts, which we've been talking about since math 3. So this is 18 degrees. And so from our last graph, we know this is 18 degrees. Add another 18, you get 36 degrees. 54 degrees, and the last one would be at 72 degrees. So sine is different because remember our sine graphs start on the midline on the y-axis, unless we of course have the phase shift. So for this one, we have 8 and -8. So then sine, if it's positive, amplitude goes up first, back to the midline, down, and back to the midline. So this would be my sine graph if this was y equals 8 sine of 5 theta. But we're just doing the R-value analysis again. So notice that this tells us where to find our first petal. So our first petal is going to be at 18 degrees. So an easier way of doing this, rather than having to always figure out what the period is and then dividing that by 4, you can just put this into equation. So for this one, notice that you're doing 360 degrees divided by n. So 360 degrees divided by n. And then remember, we're dividing that by 4. So if you have a fraction divided by a fraction, remember that's keep, change, flip. So keep the numerator and change multiplication and flip. So this is times 1/4 is the same thing as dividing by 4. And when we simplify this, 360 times 1 would be 360 over 4n. So 360 divided by 4 gives us 90 degrees over n. So that's going to tell us what our first petal is going to be. So up here, it says r equals a sine n theta. The first petal occurs at 90 degrees divided by n, or if you're using radians, it would be pi over 2 divided by n. So either way, it just depends on if you're using degrees or radians. So for this first petal, again, notice if we do 90 divided by the number, our n value, we get 90 divided by 5, which gives us 18 degrees. It's just an easier way. And again, it's the same thing what we're doing, finding the period and then dividing that by 4 to find the key points. It just puts it into a formula, so we don't have to do that each time. So that tells us where our first petal is at. And then from there, we're just going to be adding 72 degrees. So we have petals at 18 degrees is the first one. The next one would be adding another 72, so 90 degrees. Then after 90, add another 72 degrees to that, and you get 162. Then add another 72 to that, you get 234 degrees. Add another 72 to that, and you get 306 degrees. So if we graph this, we are going out a distance of 8 from the pole. So at 18 degrees would be in between 10 and 20. So we're going to go at a distance of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Would be somewhere about right there. 90 degrees out a distance of 8. Then 162 out a distance of 8. And then 234 out a distance of 8 from the pole. And then 306. And again, it should look like they're equidistant apart. So that first part, notice again that 18, so you're going from the pole out to 18 and then back to the pole. So your graph coming around like this. And again, right now, I'm not really concerned with the width of the petals or what order you're graphing them in. I just want you to know where they're going to be, and that we have 5 petals with a length of 8 spaced out 72 degrees apart. So that gives us our rose curve. So then for this one, what happens if instead of being positive 8, if we have a negative 8, that's going to again reflect it across the axis. So in this case, we're going to be reflecting across the polar axis. So if we multiply by -1, -1 times the 90 degrees over n, that's going to give us our first petal. So in this case, we get -1 times 90 degrees divided by 5, which gives us -18 degrees. Now, instead of using -18 degrees, since these are all positive values already on here, we're going to go ahead and find the coterminal angle. So remember, to find the coterminal angle, you take whatever the angle is, -18 degrees, and add or subtract 360 degrees. So we're going to add 360 degrees to find the positive coterminal angle, which gives us 342 degrees. So that wouldn't really be our first petal, but it tells us where to get the how to get that one. So -18 degrees again would be out a distance of 8 from the pole, so we have 342, so be in here. And if you think about the graph compared to the one we just did, so if I were to graph this, 18 degrees, next one is 36, 54, 72. So instead of starting at the origin and going up, we're going down first for when it's negative. So if you look here, -8 sine 5 theta. So it goes down. Our graph looks like this. So if you think about it, that if we go with -18 this direction, that's where we're getting that first petal from. You could also take the 18 degrees here and add 180 degrees to that to get a solution. Because remember, if your R value is negative, it's 180 degrees in the opposite direction. It's just easier to multiply that 90 over 5 by -1 to get that first petal, which really isn't the first one. So we're going to go backwards because we have 342 degrees. So petals are at 342 degrees. So if I subtract 72 from that, I get 270 degrees. The next one would be at 198 degrees. The next one is 126 degrees. And the last one would be at 54 degrees. So now we can go ahead and graph these. So we have, I'm going to start with 54 and go backwards. So 54 will be somewhere in here. 126 is the next one. 198. 270. And then the next one we have already, which is 342. So our graph would actually go around like this. And if we look at the one we did a minute ago, notice again, and reflects in this case across the polar axis. But that's not true for all these graphs. Sometimes it looks the same, depends on if n is even or odd and how you're going to start. But that would be negative, r equals -8 sine 5 theta. So the next one we're going to graph is r equals 6 sine 6 theta. So if you want, you could pause the pause the video to see if you can do this one on your own, and then unpause it when you're done to see if you got the correct answer. So for this one, n equals 6, which means the number of petals is equal to 2 times 6, which is 12. And the length is always equal to the absolute value of A, so the length is each petal is equal to 6. The distance apart, or between, or the space between, however you want to say that, is 360 degrees divided by the number of petals, which is 12. So the distance apart is 30 degrees. And the first petal would be 90 degrees divided by n. So notice that it's not 2 times n, it's 90 divided by n. So 90 degrees divided by 6 would give us 15 degrees. So that first petal is going to be at 15 degrees out a distance of 6 from the pole. So 1, 2, 3, 4, 5, 6. So right there. And that means our petals are at 15 degrees. And then we're going to add the distance apart, which is 30 degrees. So 15 degrees, 45 degrees, 75 degrees, 105 degrees, 135 degrees, add another 30 and get 165 degrees, add another 30, get 195 degrees, add another 30, and we get 225, 255, 285, 315, and 345. So let's go ahead and plot these. So 45 and 75 and 105, 135, 65, 195, 5, 255, 285, 315, and 345. And so you could then draw all your petals. And again, you don't have to go in the order for our purposes. You can just go ahead and graph each one. And they should all look pretty similar in shape and size. I'm just going around the circle. And again, this is not the actual order they would be graphed in. I'm just drawing the petals out. And that gives us our rose curve. So again, just to show you our R-value analysis, so if I were to graph this, R theta, and so again, we know that if we have R equals 6 sine 6 theta, so our B value is equal to 6, which means the period equals 360 degrees divided by 6. Which gives us 60 degrees. Oopsies, sorry. So that gives us 60 degrees. And then the key points are 60 degrees divided by 4 equal parts, which gives us, again, 15 degrees. So this would be 15 degrees, another 15 is 30, another 15 is 45, and 60. So for our sine graph, because it's positive, it's going to go up from the midline starting at the R. So it goes up, back to midline, down, and back. So this would be our graph. And so you can see the first petal length is out at that 15 degrees. And so again, that comes from the n 90 divided by n, or if you're using radians, it would be pi over 2 over n. So that is it for our rose curves. So knowing this information up here is helpful again. So when n is odd number, you have odd number of petals, even, you have 2 times n petal length is absolute value of A, the spacing between 360 over the number of petals, or 2 pi over the number of petals. Cosine first petal occurs at 0 degrees. Sine first petal is 90 degrees over n, or pi over 2 over n, depending on if you're using radians or degrees. And then multiplying by -1 reflects the rows over an axis. So that is it for this